So today we're going to learn about nuclear chemistry. There are 4 different types of particles. You have alpha particles, beta particles, beta minus particles, and gamma rays. The alpha particles go through alpha decay, neutrons go into protons, go into electrons. Beta decay, you've got protons going to electrons.
What are electrons?
Hey, get out of here! Electrons going through electron capture, you go in there to the protons, there's the neutrons. I'm done.
Mr. Dusso, there's still 30 minutes left in class.
I got stuff to do.
Wow, this sucks.
I know, he's only giving us 1 day to learn nuclear chemistry.
What's even worse, he's blaming it on us.
Typical Dusto.
Dusto? Could someone mention the name of such a troubled soul that he must take out his frustrations on helpless, poor chemistry students? Hey kids, it looks like you guys are having a little trouble with chemistry. Well, have no fear. I'm Supernuclearchemistry Man, but you can call me Supernuclear Chemistry.
Okay.
Right. Dude, I don't know if we can trust this guy.
I don't think he's American.
Uh-oh! I know, but I'm sitting on 89 here. I think I'll take my chances.
Dude, this is sketch.
It's so legit.
Sketch.
Legit.
Alright, when they find our dead bodies, your fault.
Alright, deal.
Haha, it seems to me that you boys have clearly made the count. Fantastic choice.
What was that low-flying private plane? In here, boys.
Did we just come out of the closet?
Yes and no. Anyway, your teacher may not have taught you this, but there are 3 main components of the atom. There's a positively centered nucleus, composing of protons and neutrons. Neutrons obviously being neutral in charge, and protons obviously being positive in charge. But the last thing is that the thing orbiting the nucleus as a whole is an electron, a negatively charged particle that is, according to the AMU's, weightless.
Radical!
Far out! You guys should come and surf up the waves of nuclear chemistry with me here in my own layout.
Cowabunga, baby!
Take a seat, boys. You too, Brad. Anyway, remember how I was talking about the protons and the neutrons? Well, collectively, they're known as the nucleons.
Jammin'!
Ditto! Okay, well anyway. So the force holding the nucleons together is known as the nuclear strong force. At normal times, the electrostatic repulsions between the 2 particles would cause them never to get close to each other. But the strong force is so strong, so binding. Look, there's an example right there.
What?
See, you guys didn't want to hold hands, but the strong force overcame you, causing there to be an attraction between the 2. Anyway, my tummy's in a bit of a hurry for some curry.
Wait, he's only Indian.
Thank God he's not.
Ah, don't you mean thank you, Shiva? And away we go. When I was your age. When I told him that he could take his curry and go back to Calcutta if he's gonna keep on insulting me like that. But then he came back with the filing restraint. So you guys remember when I was talking about protons, right?
No.
Nuh-uh.
Anyway, There are pretty much 4 basic particles to remembering all of nuclear decay. The first is beta, and then comes alpha, beta plus, and gamma rays.
My favorite's the positron.
My favorite's the gamma wave.
Maybe you guys should look at this table chart that I have right here. Alright, remember, alpha, beta, beta plus, positron for you, Nick, and gamma wave. The symbols are simply the corresponding Greek alphabets. Alpha, a sideways fish, beta, a bee, beta plus with a plus, and a gamma wave is an upside down fish. Now the charges on them specifically are +2 for alpha, -1 for beta, +1 for beta plus, and a gamma wave, seeing as it isn't an actual particle, has no real charge. The masses are 4 for alpha, 0 for both beta and beta plus, and once again, because a gamma wave is not a particle, it doesn't have mass.
Wow, that's cool.
Indeed it is.
Well, let's head back to the lair, guys.
Something isn't right here.
Wait, what is it?
Run, it's gonna blow!
All my possessions, my life's work. Oh, God.
Sick nasty! Wicked sweet!
Oh, you boys. I might as well just explain the principles behind the reaction that just took place. Otherwise, what kind of superhero would I be? See, the reaction that just took place could either have been a fission or a fusion reaction. You see, a fusion reaction is when 2 smaller atoms come together to form a bigger atom. And a fission reaction is when a huge atom breaks apart into 2.
Wait, we can't go back in there, can we?
The emission that just occurred is very, very dangerous. In fact, the reason why we can't go back in there is because the half-life of uranium-238 is 4.47 billion years.
Wow, that's long.
It sure is.
Well, what is a half-life?
A half-life is the amount of time for half of a substance to decay. In fact, this radioactive substance will continue to decay until it has stabilized. This emission is very dangerous. Remember, boys, always use protection.
In radioactive situations.
Wow, dude, this test is so hard.
Yeah. Which of the following is not a fusion reaction? I wish we had some help.
I know.
Oh my God, dude, look, it's Supernuclearchemistry Man.
Thanks, Supernuclearchemistry Man. No talking in here. What are you doing? Give me these. The nuclear fusion question. What a great question.